Welcome Java class, welcome to Unit 9. Alright, so again, we are sort of highlighting in Unit 8 and Unit 9, what we're doing is we're highlighting those three important concepts, okay, which are what? Let me just go to the next slide, which are your encapsulation, polymorphism, and class interaction. So in Unit 8, actually, y'all got a good share of encapsulation, where they were talking about how you can package these attributes and methods, right, into these objects. So that is your encapsulation. This particular unit will focus on class interaction. Remember, polymorphism is something you will do if you step into APCSA. Okay, so class interaction. There are three types of class interaction, okay? There are three types. Remember, we speak about inheritance a lot, but inheritance is not the only kind. There's inheritance, there's composition, and utility class. Before we talk about inheritance and composition, let's just get utility class out of the way because y'all have seen that before. Utility class is basically things like your math class and your expo class. These are classes which are not used to create objects, but still contain several useful methods. That's your key. They are not used to create objects, several useful methods. So that's your utility class. That's your utility class. So now we are left with inheritance and composition. Okay, so we'll talk about both of these in this unit. To understand that though, we got to understand this simple English behind the two of them. And if you understand this, you guys, and it's actually simple because we have to think of it very intuitively, okay? So there is this is a relationship and a has a relationship, okay? Is a is associated with inheritance and has a is associated with composition. We'll look at examples and you'll see how, okay? Is a and has a. The creation of new classes with the help of existing classes makes an important distinction between two approaches. And is a relationship declares a new class as a special, new, and improved case of an existing class. So let's just read that again. An is a relationship declares a new class as a special, new, and improved case of an existing class. In geometry, a parallelogram is a quadrilateral. So imagine if you have this quadrilateral class, right? You're making a parallelogram class, but parallelogram is inheriting certain things that quadrilateral has, but it's new and improved. It's a special kind of a quadrilateral. You're inheriting, though, the basics or the foundations of that quadrilateral class to then build up on your parallelogram class. So new and improved case of an existing class, this is called an is a relationship, and this, you guys, is called inheritance, okay? What about has a? A has a relationship declares a new class composed of existing classes or class, okay? Here, a line has points. So imagine you have this points class, and in order to build a line, you need to use your points class, okay? Likewise, a square has lines. In order to build a square, you have to use lines. In order to build a cube, you have to use squares. So line has points, square has lines, and cube has squares. So this is an example of composition, where one class uses another class to build itself. Okay, that's your has a relationship. If this is still vague, you guys hang on there. Okay, if you just speak it in English, sometimes it's much more easier to understand its distinction. Like here, a truck is a car, but has an engine. Like you can say a truck has an engine. You don't say a truck has a car, right? A truck is a car. So truck is a car indicates that the relationship between truck and car is inheritance. But truck and engine, a truck has an engine, that tells you the relationship between truck and engine is actually a composition. Good. Okay, let's look in a deeper example. Okay, so inheritance is the process of using features. What are these features? Attributes and methods, right? Those are the two features of a class, attributes and methods, from an existing class. The existing class is called the superclass, and the new classes which inherits the superclass features are called the subclass. So for example, here you have a car, right? Here you have a truck, a limo, and a race car. That's what they try to say in the last unit, you guys, that if you have to build a truck, a limo, and a race car, you don't have to start from them like independently from scratch. You can actually build a car class like a superclass and then inherit the general things about a car for building your truck and make it special, for building your limo and make it special, and distinct from a car and from a truck and make a race car, right? Inherit the properties of a car and make it special, and that's your race car. Okay, so these are called your subclasses, where car is called your superclass. This is inheritance. Composition. Composition occurs when the data attributes of one class are objects of another class. Okay, let's try that again. Composition occurs when the data attributes of one class are the objects of another class. So imagine you have a car class, right? And right at the top, remember how we declare the variables of the class? So those variables traditionally be something like int and double, right? But now, what if those are special data types, right? Those special data types are things that you have created. That means they are classes as well. Imagine you made an engine class and a tire class. But in order for you to build your car class, you sort of need to use these data types, the engine and the tire. So whenever the data attributes of one class are the objects of another class, that's when composition comes into play, right? In order to build my tire class, in order to build my car class, I need to use my tire class and my engine class. That's composition. So again, inheritance versus composition. In computer science, an is a relationship is your inheritance, and a has a relationship is your composition. A tire is a swing. A tire swing has a tire. Sorry. A tire swing is a swing, a kind of a swing, right? A tire swing has a tire. So this is your superclass is swing. Subclass is tire swing. Contained class is tire. And here, you guys, if you say, you do not say a car is an engine or a car is 4 tires. You say a car has an engine and a car has 4 tires. That indicates to you composition versus inheritance. Superclasses and subclasses. So one important fact you want to remember about inheritance and constructors is this. When an object of a subclass is instantiated, that is when I create an object of a subclass, the constructor of the superclass is called first, followed by the call to the constructor of the subclass. We know these constructor calls are invoked automatically, but now when you have subclasses and superclasses, where and how are these constructors going to be invoked in what order? The way it's going to be invoked is when you create an object of a subclass, first the superclass's constructor will be invoked, associated with that subclass, and then the subclass's constructor. Okay, good. So let's look at this example. So here you have this main program where it looks like you're creating an object Tom, okay, from the student class. So if you look at the student class right here, you're creating an object Tom. Okay, great. Then I do something like tom.showAge. Let's see what's in the showAge function of Tom. So I go to student and I search for showAge. I see showGrade. I don't see any showAge. And this looks like a problem. How can I access showAge from Tom? And if I notice, I can see a showAge in person. So I'm trying to do something really tricky here. I have 2 classes, right? And I'm trying to access showAge from using the Tom object, which is associated with student. As expected, this will be an error. Okay. Well, looks like what I was trying to do in this case was student is a person. So I was trying to actually use these general things about the person for my student, right? But looks like I did not write the correct syntax for it. So what I really wanted to do was my student class is an extension of my person class. Person is a general class and student is a person, right? So this tells you that the relationship between student and person is an inheritance. So what I see over here is now I create an object Tom, and can I do tom.showAge now? Yes, I very well can. Now I do tom.showAge system.out.println. So that means I would expect person's age is unknown right now. And then I do tom.showGrade. I'm calling this, which is of here, system students grade is unknown right now. So I should get both of these messages successfully now. Do you see that, you guys? All right, let's move on. So this program adds constructors to the person and the student class. Now remember, we spoke about these constructors associated with classes and what's the order in which they'll be invoked. So here I went and I created a constructor for the person class, and student, which is an extension of the person class, also has a constructor. Person constructor and student constructor. And now I created an object Tom, and I'm doing a println, just a blank line. But remember, even though in my main, I don't try to access any methods, as soon as I declare an object, constructors are invoked associated with that. But when I look at student, student is not independent, right? Student is an extension of person. And remember, when a subclass and a superclass is there, then always the superclass's constructor will be invoked first, then the subclass. So it looks like I should get person constructor, then student constructor. Voila, that's what I get. Okay, expected? Good. Private and protected access. Well, let's try to understand this. Public, private, and protected. Okay, so we've seen private and we've seen public. What is this protected? You guys will understand this now. Attributes and methods are declared public and can be accessed by methods declared both outside and inside the class. We've seen this, right, you guys? Whenever we make methods, we generally declare them public. Attributes can also be declared public, okay? And when you do so, we generally make attributes private, but they can also be declared public. And when you do so, they can be accessed by methods. They can be accessed by methods declared both outside and inside the class. Okay. Attributes and methods declared private can only be accessed by methods declared inside the class. What about protected? Attributes and methods declared protected can be accessed by methods declared inside the class or subclass. That's your key. Class or subclass. Let's look at an example. So right here in my main program, looks like I'm creating an object Tom. Okay, and if I look and it's of the student class, and student is now an extension of the person class. Okay, and I created, looks like I have constructors for both, so that tells me something, right? Constructors will be invoked. Then I try to do tom.showData, so that is tom.showData, and it looks like I'm printing the grade and student's age. And if I look at what's happening in the constructor, it looks like I'm doing two things. I'm printing student constructor and I'm setting grade to be 12, and here I'm setting age to be 17. So now I do tom.showData, and here I do something like student's age is age. In showData, I'm trying to access a variable, right, from another class, from my superclass, and I declared that private. Can I do that, you guys? Nope, that is an error. Your computer is not going to be happy. Even though person is a superclass of student, I will still not be able to access the private members, the private variables of the superclass. So how do I handle this case? Well, I make it protected, and now I can access it. And I get my person constructor, right? Then my student constructor, superclass, subclass, sys constructor. Then I did tom.showData. Therefore, student's grade is 12 and student's age is 17. Awesome. Multi-level inheritance. I'm going to pause here, you guys. We are going to actually continue this in our next lecture. Thank you.